So robots can make decisions for the worst case. So they can say, no matter what, if it's raining or not, I'm going to act in this way. Or they could plan for kind of risk-aware models. And this is a big trend in robotics, where you formally analyze how likely certain unlikely events are and try to make decisions like based on that formal analysis. But one thing we don't really do is we don't analyze how the people who are interacting with those robots perceive that risk-taking. So the project we're working on is we're taking a very simple setting where we're having a human and a robot collaborate to stack a tower of 4 blocks. And the human that's doing this interaction gets to see 2 different robots. And one robot they interact with is pretty mediocre at its job all the time, and the other robot they interact with is occasionally great and occasionally quite poor. And what we're really trying to test is, are humans that are kind of in this collaborative task more interested in working with this consistent mediocre robot, or are they willing to take risks with this robot that's occasionally great but occasionally quite poor? From my perspective, as a person who designs autonomous robots, I'm interested in what these robots should be optimizing for when they're interacting with humans. And of course, we're looking at a quite narrow context. So we're looking at this collaborative block stacking task. But I'm interested in seeing if this can inform the decisions we make about taking risks in the future. So for example, one thing we found in this project is that when the robot that the human interact with are generally good at their task, they're more willing to take risks. But if the robot is really bad at its task on average, then the humans are less willing to take risks. So maybe this can inform the optimization objectives I use in the future in robotics, where if we know the robot isn't very good at what it's doing, maybe we should make it be more consistent.
So I did my PhD in psychology and human-robot interaction, and now I work here at the Division of Robotics Perception and Learning as a postdoc. So I collaborate a lot with engineers and computer scientists, like you'll see with Ermanno and Anna later, to kind of design user studies that involve both humans and robots. In my research and also within PerCorSo, I'm especially interested in robot failures, like what happens when robots fail. And this is because even though we are making huge technical advances in the robotic systems that we are designing and building, well, I say we, but I work with amazing engineers that do the actual programming, but they will still fail. It's impossible to guarantee a perfect interaction with a robot. And so we really need to be designing these failure-aware systems, and we need to know what is happening in an when an interaction between a human and robot is happening and there's a failure. We need to have strategies in place to kind of recover from these failures, to make sure that the trust between the human and the robot isn't damaged, or if trust is damaged, that we can repair it.
Recently, me and Rebecca from the postdoc from PerCorSo as well, we've done this PerCorSo project in which we were investigating a more human-centered interaction way, how the response time affect the interaction with people. So what we basically did is constructing a full interaction, pretending we were in one of public spaces, for instance, like a restaurant or museum. The robot was tasked to be the waiter or the guide of the museum, so they had to interact with people through a spoken communication, and then we investigated different architectures of response processing and generation. This is done through LLMs usually, but there are different ways to do that, and we managed to decrease the response time through an offloaded architecture. And what we wanted to investigate is the response time affecting the user's experience when they are communicating with the robot. So we basically compared 3 different conditions. The one was our offloaded condition that was the fastest among all the 3. The other one were relying on ChatGPT, Well, ChatGPT is like a third-party company that provides us, like, under payments for query. They provide, basically, we send a string what the user said, and they give us an answer. Depends on the network congestion, depending on their status, it can vary the time of like inference and the time of that we need to wait for getting an answer. So we don't know how much time it's going to wait. What we notice is that when there are some ideal scenario, we can get an answer quite quickly. When this scenario is not any ideal, and this is not very unlikely actually, we're going to wait more for getting an answer. So based on these three conditions, which is again our offload structure, the like ideal case scenario ChatGPT and the slow case scenario ChatGPT, what the user preferred to interact with, which condition. So was the same robot doing different interaction with these different conditions, and what emerged is that they clearly wanted to interact with the fastest robot as compared on the slowest robot. But if they had to choose between the fastest and the slowest, then we realized that that interaction was more beneficial when the response time was faster. So my idea is that we want robot to do the right things and make the good decision, but I think we want also robot to do the good decisions at the right time. I think the most useful insights and the most useful things that we can get from robots is when they are going to do something for us or with us, and not when they are just there, like some, not human being, but some object being on their own.
I think it's been absolutely fascinating to get to work with people with such different perspectives. And I think I come from a mathematical modeling background. I tend to look at like kind of a game theoretic perspective in robotics, and talking to people who think about risk, who think about failures, who think about safety, but in a completely different context than I do, has really allowed me to like broaden my understanding of the field, and also allowed me to like find new interesting research questions at the intersection of our two work. It's been fun.